Hi everyone. Today we are going to talk about the gravitational potential energy. So actually gravitational potential energy, it's the energy gained by the object due to its position above the Earth's surface. So this is the definition. The energy is stored in the object due to its position above the Earth's surface, which means that the gravitational potential energy, it's an energy which depends on the height of the object. So actually, let's understand and know the formula of a gravitational potential energy. So gravitational potential energy formula is m, g, and h. So it's mass, gravitational field strength, and height. M stands for mass, and it's in kilogram. G stands for a gravitational field strength. The gravitational field strength is a constant number, which is 9.8. Sometimes we can use it as 10, but actually it's 9.8, and its unit, it's Newton per kilogram. So it's Newton per kilogram. So this is gravitational field strength. Then the height. And when I'm talking about the height, I'm talking about vertical distance from the Earth's level to the point. For example, if I know that this ball right now has a mass of 2 kilograms and the gravitational field strength, I'm going to just use it as 10 to make the calculation easier. Then the height, I will show you where is the height. This will be the height from this point to that point here. So this is the height. So the height is, say it's 5 meters. Then I ask you, what is the gravitational potential energy? So gravitational potential energy, it's mass times the gravitational field strength times the height, mgh. So m is 2 kilograms times g, which is 10, times the height, which is 5. Okay, so this is equal 2 times 5, 10. 10 times 10 is 100. What is the unit? Is joule. So actually, a gravitational potential energy is mass times g times height. So E equal mgh. But as you can see here, mg, this is the weight. You know, so gravitational potential energy, I can just simply say its weight also times height. It's correct. Why we just need this point of information, this piece of information? Because sometimes he doesn't give you the mass, he give you the weight. Say, for example, the weight for this one, okay? So the weight for this mass, it was like 100 Newton. Remember, it's not kilogram, it's in Newton. So the weight of this one, it's 100 Newton. And the height equal 3 meters. Then I ask about the gravitational potential energy. In this case, we know that it's mg times height. But remember, mg, this is the weight. And you already have here the weight. He told you the weight of the object in the question. So the weight of the object, this means I'm going to just remove mg and put the weight, which is 100, times the height, which is 3. So this is equal to 300 joule. So you can use the weight directly to figure out what the gravitational potential energy. So weight times height equal gravitational potential energy, because mg here stands for weight. So if you have the weight, you can use it directly. Okay, guys, I hope you got this. Let's take another example. Okay, guys, let's answer this problem together. So a rocket is stationary at a height of 3,000 meters. So this is the height, 3,000 meters. It's a gravitational potential energy. So here we have the gravitational potential energy. Then he asked about the mass. So mass question mark. So the question is, This is the rocket. We have the mass. He just asked about the mass. We have the height, which is 3,000 meter. Then we have gravitational potential energy, which is 300 kilojoule. So in this case, we need to just figure out the mass. So write the formula. So gravitational potential energy, it's M, G, and H. I told you before, I asked about the mass. So this is the mass. Everything with the mass or the variable he asked for, just put it down. So I have within the mass GH, put it down. So here G and H. And the other side here, which this side, put it up. You can use this way. So at the end, mass equal gravitational potential energy, G divided or G times H. Or you can use the triangle. If you like this way, you can use the triangle. How can you do this? Also, by the same way, this is a gravitational potential energy. This is M, G, and H. If I ask about everything is divided. So if I ask about the gravitational potential energy, so gravitational potential energy, M, G, H times. If I ask about the M, so gravitational potential energy divided G and H. So M equal gravitational potential energy divided G and H. If I ask about H, the height, so it will be, so this is the height, it will be gravitational potential energy divided mg. So gravitational potential energy divided mg. Either way is correct. You can just use any one of them. It will give you the same thing at the end. So I ask about the mass, so I put the mass on this side to be a subject, then make a fraction. Anything within the mass, I will put it down. Anything on the other side, put it up. By this way, very simple. Then, so gravitational potential energy is 300 kilojoule. Remember, gravitational potential energy is measured by joule, not kilojoule. Height is measured by meter, not centimeter, not kilometer. Mass is measured by kilogram, not gram, not megagram. So if you have kilojoule, kilo in physics has value which is 1,000. So if you need to convert it from kilojoule to joule, this means you need to remove the kilo, so put the value of the kilo. What is the value for the kilo? It's 1,000. So kilojoule to be converted to joule, I will just make it times 1,000. So here we have a 300, so 300 kilo, which means it's times 1,000 because this is the value for kilo. Now it's joule. So 300,000 joule. So now it is 300,000 joule. Okay. The mass is, the height is by meter. Yeah. Okay. This is correct. So I can use it directly. So before you start to answer, just be sure you have the gravitational potential energy in joule, you have the height in meter, and you have the mass in kilogram. This is very important. G equal actually 9.8 times, or you can use it as 10, no problem, at least at this level. And height here, which is 3,000 meter. Use your calculator and figure it out. This is 300,000. Yes, 300,000, okay, joule. So then you can use your calculator and figure out the answer, and the answer at the end will be by kilogram. So the answer will be by kilogram. So now it's a gravitational potential energy, which is 300,000 joule divided by G, which is 9.8 constant number. You need to know it, okay? And this one will be 3 times the height, which is 3,000 meter. So the answer would be 10.2 kilogram. So this would be the answer, 10.2 kilogram. I hope you got this. So, second question, calculate the mass. He also asked about the mass. So, question mark, just calculate the mass of an object has a gravitational potential energy 250. So, gravitational potential energy here 250 joule. Yes, this is true. It doesn't need any conversion. And then we have the mass. He asked for mass question mark. And we have here 20 centimeter. So this is the height. So the height is 20 centimeters. So the height equal 20 centimeters. But I will stop at this point because I never use centimeter. So how to convert it from centimeter to meter? We can do this by dividing the number by 100. So 20 centimeters divided by 100, it becomes meter. So it gives you 0.2 meters. So 20 centimeter equal 0.2 meter. So what is the formula? We have this gravitational potential energy equal mg and h. So he asked about the mass, as I told you. So mass equal everything within the mass will be down. So this is g and h within the mass. So this is g and h down, and the other side will be up. So this side here, gravitational potential energy will be up by this way. So what is the gravitational potential energy? Actually, it's 250 joule. So there is no need to convert anything. Gravitational potential energy 9.8 or 10. Then the height, which is 0.2. You can't use it by centimeter. You need to convert it. So at the end, you can use your calculator to figure out what is the answer. 250 divided 9.8 times 0.2. So at the end, this is equal 127.6. Okay. And he asked about what is the mass. So this will be in kilogram. So also we need to know what are the factors affecting gravitational potential energy. Actually, from the formula, you can just figure out what are the factors affecting gravitational potential energy. Gravitational potential energy, mass times the gravitational field strength times the height. E equal mgh. So actually, it depends on the mass. So gravitational potential energy is directly proportional within the mass. So at the mass increasing, gravitational potential energy increasing. If the mass is doubled, so the gravitational potential energy is doubled. If the mass is tripled, so gravitational potential energy will be tripled. So actually the relation between gravitational potential energy and the mass is directly proportional. So gravitational potential energy is directly proportional to the mass. Also, we have a relation between a gravitational potential energy and the height. So gravitational potential energy within the height. Okay, so gravitational potential energy within the height also directly proportional, which means if the height is doubled, so gravitational potential energy will be doubled as well. So gravitational potential energy is directly proportional to the mass or to the height, which means the greater the height or the greater the mass, the greater the gravitational potential energy. So you can just write this. The greater the mass or height, the greater gravitational potential energy. So now we explain together. Gravitational potential energy is the energy gained by the object due to its position above the Earth's surface. The greater the height, the greater the mass, the greater the gravitational potential energy. Also, we explain that gravitational potential energy, its mass times the gravitational field strength times the height. So E equal mgh, okay? Mass, field strength, the gravitational field strength, and the height. Okay, I hope you get this, guys. Thank you very much for your watching.